Welcome to Science Course. This is lesson number 1, School of Elements. My name is Sunita Mutha and I will be your lesson instructor. I am supported by StudActive team. Now let us see the merits of modern periodic table. First, all isotopes of the same elements have different masses but same atomic number. Since they have same atomic number, they will have the same position in the periodic table. They need not have any different position as observed in Mendeleev's periodic table. Hence, both chlorine 35 and 37 will be placed in the same position as we can observe in this modern periodic table. Second, when elements are arranged according to the atomic numbers, the anomaly regarding certain pair of elements in Mendeleev's periodic table disappears. Example, cobalt and nickel. Let us consider two elements, cobalt and nickel. The atomic number of cobalt is 27 and that of nickel is 28. Hence, cobalt will be placed before nickel. But in Mendeleev's periodic table, we know that the atomic mass of cobalt was 58.93 and that of nickel was 58.71. Therefore, cobalt will come first due to its atomic number and then nickel, though its atomic mass is greater. Next, in modern periodic table, looking at the position of any element, we can state its electronic configuration. For example, let us pick up sodium. Since sodium belongs to third period, hence it will have 3 shells. Also, sodium belongs to group 1, hence the last shell will have 1 valence electron. Hence, the electronic configuration of sodium is 281. The next topic, that is periodic properties. Now, what do you mean by the word periodic properties? The properties which show gradual variation in a group and in a period, and they repeat themselves after a certain interval of atomic number are called periodic properties. Now, which periodic properties we are going to discuss about? We are going to discuss about 3 periodic properties, namely valency, second atomic size, and third metallic and non-metallic character. Let us start with valency. Now, what is valency? Whenever an element combined with another element, it will either give or take, it will either give or take or share electrons. For example, the sodium has got electronic configuration 281, chlorine 287. To attain the octet state, it will give away the last electron and hence the valency of sodium is 1. On the other hand, chlorine will receive 1 electron and the outermost shell now has 8 electrons. Hence, now the new electronic configuration of chlorine is 288 and it has attained its octet state. So, valency of sodium is 1 and also of chlorine is 1. Now, the elements which belong to the same group have same number of valence electron. Let us see the example again of lithium, sodium, potassium. You can see the electronic configuration 2, 1, 281 and 2881. All 3 of them can give away this last electron easily and hence they have the same valency. Let us understand the gradation of valency when we go from left to right across a period. Lithium, whose electronic configuration is 2, 1, has valency 1 because it can easily give away this electron and attain its duplet state. Beryllium has got electronic configuration 2, 2. So, the valency of beryllium will be 2. Boron has got electronic configuration 2, 3. Hence, boron can give away this 3 electron or share this 3 electron. So, the valency of boron is 3. The next element is carbon in this period, whose electronic configuration is 2, 4. Carbon can share these 4 electrons and attain its octet. So the valency of carbon is 4. Let's go to the next element. After carbon, nitrogen. The electronic configuration of nitrogen is 2, 5. Now, nitrogen will take 3 electrons rather than giving electrons. So it will take 3 electrons and attain its octet state. So the valency of nitrogen is 3. Similarly, oxygen has got electronic configuration 2, 6. Oxygen will take 2 electrons and attain its octet. Fluorine electronic configuration 2, 7 will take 1 electron and attain its octet. Neon. Neon has electronic configuration 2, 8 and hence its valency is 0 because it already attains its octet state. So it will not give, take or share electrons. So the valency of neon is 0. So we see that the valency in period 2 increases from 1 to 4 up till carbon and then decreases from 4 to 1 up till fluorine. So the valency across a period when we go from left to right increases from 1 to 4 and decreases from 4 to 0. Let us see the next property, atomic size. Now, before learning atomic size, let us see what is atomic radius. We all know in a circle that the radius is the distance from its center to any point on the circle. Similarly, atomic radius is the distance between the center of the atom, that is nucleus, to the outermost electron in the outermost shell. Now let us see what happens to the atomic radius of the elements in a group. Let us consider group 1A. The first element of group 1A, that is hydrogen, has only one shell. Next element, lithium, has 2 shells. Next element, sodium, has 3 shells. As we go down, the number of shells will go on increasing and hence the atomic size will also go on increasing. So in general, we can say that as we go down a group, the atomic size increases. Now let us see what happens to atomic size when we go from left to right across a period. Let us take the example of sodium, the third period. Sodium has electronic configuration 281. Next element, magnesium, has electronic configuration 282. We know that nucleus is positively charged because of protons and electrons are negatively charged. So there could be a pull from nucleus towards the electron. If there are more number of electrons, this pull will be greater. Hence, the pull of nucleus on the electrons of magnesium in the outermost shell will be greater as compared to the pull of nucleus of sodium. As sodium has only 1 electron, while magnesium has 2 electrons, hence there will be a greater pull of nucleus. So the size of magnesium would shrink as compared to sodium. Similarly, when we go to the third element of this period, that is aluminium, it has 3 electrons in its outermost shell. More number of electrons indicates greater pull from the nucleus, and greater pull from the nucleus indicates more shrink, which reduces the atomic size. So in a period, when we go from left to right, the atomic size decreases. So sodium is the largest element in period 3. Let us learn the next property, that is metallic and non-metallic character. Let us see what is the gradation in this property. Now, what do you mean by the word metal? Elements are metals if they donate electrons. Elements are non-metals if they accept electrons. Now, who will donate electrons? Electrons will be donated by the elements who have 1, 2 or 3 electrons in their outermost shell. And who will accept electrons? Electrons will be accepted by those elements which have 5, 6 or 7 electrons in their outermost shell. We know in our periodic table that sodium has electronic configuration 281, magnesium has electronic configuration 282 and aluminium has electronic configuration 283. Hence, all these three can easily donate electron and attain their octet state. Since sodium has 1 electron in its outermost shell, its atomic size is also greater than magnesium or aluminium. Hence, the nuclear pull on this electron is less as compared to the nuclear pull of electrons of magnesium or aluminium. Hence, sodium can easily give away its valence electron as compared to magnesium or aluminium. So, we can say that sodium is more metallic than magnesium. Similarly, magnesium will be more metallic than aluminium. So, we can generalize that as we go from left to right across a period, the metallic character decreases while the non-metallic character increases. Now, let us see what happens to metallic and non-metallic character when we go down the group. Let us consider the examples of lithium, sodium and potassium. Lithium has electronic configuration 2,1, sodium 281, potassium 2881. Now when we see the atoms of these elements, it will be observed that there is a large distance between the nucleus of atom of potassium and the last electron, while minimum distance is there in lithium. Hence, the nucleus hold over the last electron in potassium is weaker as compared to lithium. Hence, potassium can easily give away this electron and not so as easy for lithium. So, potassium will be more metallic as compared to lithium or as compared to sodium. So, as we go down the group, the metallic character increases. So, let us revise what we have learned in this chapter, School of Elements. We have learned what is classification, need of classification, attempts of classification by Dobereinius, Newland, Mendeleev and Moseley. Why were these three rejected and why was modern periodic table accepted? We have learned features, merits and demerits of this periodic table. Also, we have learned periodic properties like valency, atomic size, metallic and non-metallic character and their gradation in groups as well as periods.